The network of 6 capacitor is as shown in figure. The equivalent capacitance between point A and B is. So here we are having a network of 6 capacitor. Now as far as this network is concerned, look at capacitor C2 and that of C1. Similarly, capacitor C5 and that of C6. So here C5 and C6 they are connected in parallel. Similarly, C1 and C2 they are also connected in parallel. So as C1 and C2 they are connected in parallel. So what is the effective of C1 and C2? Say C12, it must be equal to C1 plus C2. What is the value of C1? Value of C1 is 2C and that of C2 is C. So 2C plus C means effective capacitance of C1 and C2, it is 3C. Similarly, C5 and C6 they are connected in series. So effective capacitance of C5 and C6 is C5 plus C6 because they are connected in parallel. So when capacitors are connected in parallel, there will be an addition of capacitor. What is C5 here? Value of C5 is C and that of C6 is 2C. So it is equal to 3C. So C5 6. So see here, this pair is replaced by a single capacitor of value 3C. This pair is replaced by a single capacitor of value 3C, and these C3 and C4 they remains as it is 3C and 3C. So see here, the same configuration, same circuit can be redrawn like this. Here is the replacement of capacitor 1 and that of 2. It is a single capacitor of value 3C. Capacitor 5 and 6, its effective capacitance is 3C. So it is C56 is equal to 3C is equal to what? 3C. And here C3 and C4 they remains as it is 3C and 3C. Now look at this. This upper combination, it is a series combination of two capacitor. Lower one is also a series combination of two capacitor. So the effective capacitance of C3 and C56 is equal to 1 upon C3 56 is equal to 1 upon C3 plus 1 upon C56, because when capacitors are connected in parallel, reciprocal of their effective capacitance is the sum of reciprocal of individual capacitance. So 1 upon C356 is equal to 1 upon 3C plus 1 upon 3C, that is equal to 2 upon 3C, or C356 is equal to 3C divided by 2. 3C divided by 2. Similarly, here C12 and C4 they are in series. So 1 upon C124, their effective value of series combination is equal to reciprocal of first capacitor 1 upon C12 plus reciprocal of second capacitor 1 upon C4, that is equal to 1 upon, what is C12? It is 3C and C4 is also 3C. So that is equal to 3C is LCM and 1 plus 1 it is 2, that is 1 upon C124. Therefore, effective capacitance is equal to reciprocal of this is 3C divided by 2. So this is equation number 2. So see here, C356 means this series combination is replaced by a single, this is our point A, replace this series combination by single capacitor. C356 is equal to what? 3 by 2 C, 3 by 2 C, and replace this lower combination again by a capacitor C124 equal to 3C, equal to what? 3C, and here is the point A and that of B. So between the point 3 by 2C, so between the point A and B, now we are having parallel combination of 3 by 2C and 3 by 2C. So effective capacitance between point A and B. Whenever capacitors are in parallel, there is addition of capacitor, that is equal to 3 by 2C plus 3 by 2C, it means it is equal to 3C. So the effective capacitance between point A and B is equal to 3C. So out of 4 options, look at which option is correct. Option D is the correct option, that is 3C.